We first define an observer who is watching something. Say somebody is watching a particle, looking at a particle. That particle changes its position with respect to the observer. And if that happens, then we say that the particle is in motion with respect to the observer. Sometimes it happens that the position changes with respect to one observer, but it does not change with respect to another observer. Say for example, you are inside a train and the train is moving. Now you look at a particle on the window of the train in the compartment. For you, that particle may not change its location for you, but for somebody who is looking at the train from outside, for that person, the particle would be changing its position. So that particle, for you who is inside the train, may not be in motion, but for somebody looking at the train from outside the train, for that person, the particle could be in motion. So when we discuss motion, we must first see who is our observer. With respect to that observer, something could be in motion or not. An aeroplane must be traveling very fast, but people inside the plane can talk to each other. A person can even have a cup of coffee. It doesn't fall, even though the person is inside the aircraft, which could be traveling rather swiftly. So for that person who is having the cup of coffee, the cup is not in motion. So who is the observer? That is the key point. Now, to define many parameters, first we need to talk about distance and displacement. As particle moves, its position changes. Distance simply means the actual distance covered. Say for example, some ant is crawling on the whiteboard, and this is a path the ant follows. Then the distance is the total length. Distance is the total length that the ant has moved by. That is the distance of the journey. So when you are talking about some motor car traveling on the road, then the amount of fuel that is consumed, that depends on this distance covered. Fuel consumption depends on the distance covered. A person has traveled 5 kilometers, 10 kilometers. When we say, then we are talking about distance. Now, how about displacement? Before I talk about displacement, I must give you an idea about two types of physical quantities, scalars and vectors. In physics, there are several quantities that try to explain the concepts. For example, velocity is a physical quantity, displacement is a physical quantity, acceleration is a physical quantity, torque is a physical quantity, energy is a physical quantity, and there are so many of them. Some physical quantities are just numbers with suitable units, but they don't have any direction of their own. For example, distance. Today I traveled 10 kilometers. Where? I don't have to tell. If I am talking only about distance, I don't have to tell. I traveled 10 kilometers. Where did I go? Nothing is required if I am just talking about distance. Some physical quantities do not bother about the direction. They do not bother about direction. They are called scalars. Distance is a scalar quantity. So I traveled by 10 kilometers. 10 kilometers is distance. It does not require any direction. But there are physical quantities that require direction. For example, displacement, velocity, acceleration, force. Now suppose I say the same statement. Today I traveled by 10 kilometers in north direction. In north direction. Traveled by 10 kilometers. Where? If I don't say anything and if it is not required, I am talking about distance. 10 kilometers in north direction, that is displacement. When you are talking about displacement, you must tell the direction or it would be an incomplete answer. I was talking about vectors and scalars. There are other vectors, other physical quantities that require direction. There are other scalars, other physical quantities that do not require direction. For example, energy. Energy does not require direction. Velocity requires direction. Speed does not require direction. I am going in a motorbike and my speed is 80 km per hour. Alright, no direction required. But I am traveling in a car which is moving at 80 km per hour, heading towards south. Now I am talking about velocity. Velocity would always require direction. Speed will never require direction. Distance will never require direction. Displacement will always require direction. A scalar quantity will never require direction. A vector quantity will always require direction. So that's about scalars and vectors. Any questions up to this point? Let me know.
No, sir.
Okay. Now, I was talking about displacement and then I moved on to scalar and vector. In such a situation, what you see on the board an ant crawling on the board following that path, displacement is this. This is a displacement. Initial and final points, just join them. That is the displacement, and the direction is from initial to final. That is displacement. Without arrow, technically not full answer. A vector has got two things. Vector has got the magnitude and the direction both. A scalar has got only the magnitude. When we say magnitude in physics, then we make use of units. I traveled by 3. I traveled by 3. What 3? Absurd. Absurd statement or incomplete statement. I traveled by 3 kilometers. Now it makes sense. When we talk of magnitude, it is some number followed by some unit. 3 what? 3 kilometers, 3 meter, 3 centimeter. 3 alone doesn't really make too much of sense. So in physics, when we talk about the magnitude, how big something is, then we tell it by some number followed by some unit. And that unit depends on which physical quantity are you talking. Are you talking about speed? Are you talking about distance? Which physical quantity are you talking about? But all physical quantities have one single rule. If you want to tell the largeness, it is the number followed by the unit. Yes, is there any question? If so, let me know. Okay. Now, vector is a physical quantity which is vector, requires magnitude, how large it is, and the direction both. So magnitude will be told in some number followed by unit. And then direction, that's why you see that arrow. Direction can be told by arrow. Direction can be told in a different language, that it's in north direction, it's in south direction. In some language, one can tell the direction. Sometimes you can use angle also. You can say it is going at this angle. That also tells the direction. So direction can be told by arrow. Direction can be told by something like north, south, directions, angle, etc. Whether the physical quantity is a scalar or vector, it has to have some magnitude, some value. And that value is some number followed by the unit. In case of scalar, that's it. Some number followed by unit. That's it, stop. In case of vector, that's not all. Some number followed by unit, and then you need to tell the direction. Now, in case of displacement, whatever the path actually that somebody has taken, that doesn't really matter. That doesn't matter at all actually. For example, if the ant follows a different path, say it goes like this, but reaches the same final point, in that case also, I will get the same displacement vector. Displacement vector means take the final point, take the initial point, and join those 2 points by a straight line. And then mark an arrow and that arrow should be from the initial towards the final position. So now that line is telling you about the vector, which is a displacement vector. A very interesting thing is when displacement is zero. Say, for example, somebody goes to the market and comes back. Somebody goes to the market and comes back like this. Going to the market, which is at B, and then coming back to A. Your final point is same as the initial point. Final point is also A, initial point is also A. Market is at B. But the full journey, if you see, full journey means going to the market and coming back. Final point is also A, initial point is also A. So when this type of thing happens, then what is the displacement? Anybody?
Zero, sir.
Zero.
Zero. Zero.
Sir, zero.
Displacement is zero. Yes. So displacement is zero in such a case. Now, if somebody has gone to the market by some car or by some vehicle, whatever, then there is some petrol consumption in or whatever fuel consumption in that vehicle, isn't it? So displacement is sometimes very unhelpful in doing some calculations. You want to know how much was the fuel consumption for this round trip. Displacement is zero. It's of no help for such calculations. So for that calculation of fuel consumption, you need distance. So sometimes distance knowledge can be very useful. But displacement is also useful on several occasions. For example, aircraft. Now when a train goes from one point to the other, or the bus goes from one point to the other, then there are all turns here and there, and if it travels large distance, then that large distance becomes even larger. Say for example, you want to go from one city to the other city by train, and train can't go straight because of the track. So train cannot take the shortest distance between A and B, right? Train can go whatever the track is, but aircraft can go almost straight. So in such a case, displacement concept is useful. So displacement is shortest distance, you can say, between 2 points. Magnitude-wise, displacement is the shortest distance between 2 points is not a perfect definition. Displacement has direction also. So if somebody says displacement is the shortest distance between the 2 points, it's not a complete answer, because displacement has direction also. You can say that its magnitude. Its magnitude is equal to the shortest distance between 2 points. So if I have a shortest distance, right, then that is the magnitude of the displacement vector. Can you tell me in that drawing what is the direction of the displacement vector? Path is from A to B. So what is the direction of the displacement vector? Any problem? Any problem? If that arc is from A to B, then what is the direction of the displacement vector? Yes, anybody?
Sir, northeast.
A to B?
So northeast.
No, northeast you cannot say because I have not marked north, south, east, west in that board. If I had marked north, south, east, west, then you could tell. In that board, whatever drawing you have, what would you say? Just making use of that drawing which is on the board. Well,
Towards B.
if the actual towards B, yes, towards B is right. If the travel is along this curve, then join the final point to the initial point. This is the magnitude of displacement vector. Magnitude of displacement vector. A vector has magnitude, vector has direction. What is the direction of this displacement vector? It is from initial towards the final. Always remember this. Direction of displacement vector is from initial towards the final, not the other way. So if I ask you another question, that some ant crawls on this whiteboard in this manner, this is point P, this is point Q. Then what would be the displacement vector? Okay, now you can use the board if you want, but try to use it in a neat manner. There is an option to draw the line. There is an option to draw the line. You can, yes, somebody has done it. That's the way things should be done. Look at this straight line. Just a moment. Let me delete these others. Can you draw that straight line again? Yes, that's good. Now what you have drawn is the magnitude of displacement vector. Can you give it direction also by marking the arrow? Will it be P to Q direction or will it be Q to P direction displacement vector? Okay, that's fine. That's fine. So it is always from initial towards the final displacement vector. Now suppose I give you this simple problem that this is a circle whose radius is, say, 7 meters. Whose radius is 7 meters, and a particle travels from this point A to diametrically opposite point B. Diametrically opposite point B via this route. It travels like this. Then what is the magnitude of displacement? Magnitude of displacement. So what's your answer?
14 meters, sir.
Correct. 14 meters. Yes. That's perfect. Can you show it on the board now? You can use the board. Displacement vector, can you show it on the board? Yes. Direction. Yes. So that arrow tells the direction, and 14 meter it should be. 14 meter is the magnitude of the displacement vector. Perfect. Now can you also tell me what is the distance traveled in this journey? What is the distance traveled in this journey?
Sir, half the circumference of the circle.
Correct. And how much is that? Half of circumference is how much?
22 meters, sir.
5 into 7, 22 meters.
22. 22 is right.
5 into 7.
So, yes. So pi r, pi is 22 by 7 into 7, that is 22 meters. So 22 meter is the distance, and 14 meter is the magnitude of displacement. Okay. Now suppose we change the question a little bit. Suppose we say that particle reaches B, but doesn't stop, again goes to A, and then again goes to B. So basically one full turn, then half more turn. Will the answers change at all?
No, sir, displacement won't change.
Displacement won't change. But how about distance?
Distance will change.
Distance will change?
Yes, sir.
Yes, sir, it will.
Yes. So how much will be the distance now? One full circle?
66
2 pi r? 66. So 2 pi r, one full circle, plus half circle more. So 2 pi r plus pi r. So that is 3 pi r. And yes, I think it should be 66 meters. Any questions? Yes, carry on.
Sir, will distance be equal to displacement?
Sometimes yes, sometimes no. And here is the explanation. Okay, technically, the technical answer is no. Technical answer is no. Because distance is a scalar and displacement is a vector. A scalar can never be equal to a vector. So that's a technical answer. But what you are asking, I think, is magnitude. If you are asking is distance equal to the magnitude of displacement,
Yes, sir.
then the answer is yes. Any question? Yes, you said something?
No, nothing, sir.
Yes. So if you are asking is this distance equal to the magnitude of displacement,
Yes,
then answer is this. Then the answer is that it depends. You saw in this case that distance was never equal to displacement. Distance was never equal to displacement magnitude wise. But sometimes it can be. Say it's a motion in one direction and in one dimension, straight line. Now, suppose a particle is going only towards right side, right? In that case, there is no difference between the magnitude of displacement and distance. If it goes in only one direction. Yes, any other question? All right. So what's your answer?
It can have zero displacement.
Okay, why?
Sir, it can have only if it comes back to its initial point.
Yes, yes. Initial point is same as the final point. Initial point is same
when
as. Yes, go ahead.
Hello?
Yes, I can hear you. Just go ahead.
So, when an athlete runs in a 400-meter race, he comes back to his original position. There the displacement is zero. Distance covered is 400 meters.
Perfect. Perfect. So that's the case of moving in one direction, the one dimension, certain race. The most general answer is this answer. If the initial point and the final point, if they are the same, doesn't matter if it is a straight line motion, it is a planar motion, or even three-dimensional motion. Imagine a missile fired, some like a Hollywood movie for example. It is fired at a point, travels in the space, and imagine it comes back to the same position, right? Even in that case, the displacement is zero. Any questions? Let me know. Yes, anybody?
Sir, is it 10 root 2 meters?
10 root 2. Let me see. Two minutes 20 seconds. 120.
So 20 meters? No.
40.
40 meters, sir.
140 seconds. In 40 seconds, 10 meters. So let's say the farmer starts from here. 10 meter, 40 seconds, 40 more, 40 more.
75 meters.
Let's see. Wouldn't the farmer be here?
So 35 meter.
Let me complete. Yes, I was saying 40, 10 meter in 40, 40 plus 40 plus 40, 120, 20 second more. So 5 meters, 5 meter. It should be, farmer should be in the midpoint. Do you agree with this, that the farmer should be at the midpoint right here?
Hello? Sir, 35 meter?
Yes, I know you're saying 35 meters, but before coming to that, do you agree with this or not? Will the farmer be here or not? Midpoint. Yes?
Yes, sir.
Okay, take mark. Yes. How about others? Okay, if you agree that it is this case, then what should be the answer? If you don't agree, then you must tell me why is it so. And if you agree, tell me the answer then.
So 35 meter.
Well, if you agree farmer is here, then how can it be 35? How can it be 35 then? 5 meters.
Sir, does it mean that he travels one side in 40 seconds or the whole square field in 40 seconds?
Okay, that's a good question. Okay, I think you have got a point. You're right. First line means that the total is 40.
So, sir, that means that he should be in the diagonally opposite point from where he started.
Yes. Just hold on. Yes. So what we discussed is based on one side covered in 40 seconds. But if 40 seconds is for the whole square, then it means one side is covered in 10 seconds. Right? If 4 sides are covered in 40 seconds, then one side is covered in 10 seconds. How much time is elapsed? 2 minutes, 20 seconds. 140 seconds. Well, just imagine 140 seconds. 40 seconds back home, next 40 seconds again back home, next 40 seconds again back home, then 10 seconds, then 10 seconds. You're right, diagonally opposite. So what's the answer? If the farmer is diagonally opposite, then what's the answer?
Sir, 10 root 2, sir.
10 root 2. 10 root 2. Now this first sentence can be a little confusing. So anyway, we have done both cases we have done. If it is 10 meter side in 40 seconds, if it is 10 meter in 40 seconds, then what is the answer? This is the answer. Farmer is here, displacement is 5. And if the whole square is covered in 40 seconds, if that is what it is, then farmer is here and it is 10 root 2 meters. And displacement is this in that case. This is the displacement vector in that case. In this case, this is the displacement vector. Any clarifications, any questions if you have, let me know. Now, the question is this. Particle travels exactly like this, right, up, left, and finally reaches here. The question is, what is the displacement? Both magnitude and direction. Now in this case, because north, south, east, west directions are given, you can say towards this direction, whatever north, south, east, west. You can say that way. You can also use angle. You can say this much degree from this direction. Whatever way you like, you can give your answer. No, not now. This is your assignment question. So you have to submit it from the website. Any clarification if you need, let me know right now. Yes, just go ahead. Just go ahead.
Sir, how to save?
Are you asking how do you submit? Are you asking how do you submit?
Yes, no, sir. How to save this page? No, sir. How to save this page?
Well, I will tell you just in a moment. First, I will stop the recorder. So any other clarification before I answer how to save this page or how to submit? Any other question regarding this question? All right, fine.